Next up, Andy already plugged just a couple of minutes ago that his colleague Mark Downey would be here to talk about debugging in Visual Studio. So keeping with the theme of Visual Studio, working to improve .NET productivity, Mark Downey, who is a senior PM on the Visual Studio team, is going to talk about the ways to effectively diagnose and debug .NET applications in Visual Studio. So passing the torch off to you, Mark. Welcome.
Hi, Leslie. Thank you very much. Hi, everybody. My name is Mark Downey. I'm a program manager on the Visual Studio Debugging and Diagnostics team. And I want to take the opportunity to talk to you about how you can effectively diagnose and debug .NET using Visual Studio. So my talk today is going to be kind of split into three topics. I'm going to be talking about debugging .NET with Windows subsystem for Linux. I'm then going to go talk about how we can enable certain debugging tips and tricks to make your life easier as you kind of navigate Visual Studio on a day-to-day basis. And also I wanted to kind of introduce the perf tool and how that can be helpful in helping you kind of see day-to-day issues that might come up in your code, that kind of hidden perf issues that can kind of be revealed using that kind of tool. So first of all, talking about Windows subsystem for Linux. Well, what is it? Well, it actually is it's a tool that allows developers to run a Linux environment directly on Windows, completely unmodified. And unfortunately for us, it comes without the overhead we normally associate with virtual machines, and certainly the overhead we associate with dual boot setup. So what you can do as a user of Linux distro is go to your Microsoft Store on your Windows 10 machine, go find the Linux distro that you like the most. You can install it directly from the Microsoft Store, and then you can run common commands like grep and awk, and you can also run bash shell scripts and command line applications and so on and so forth. So WSL2, Windows Subsystem for Linux 2, is simply the latest iteration of the Windows subsystem, and it has much improved speed over the original incarnation. So why would you debug with WSL2? I know many of you are thinking that I have containers locally, I can remote debug over SSH, and all those are good. But we believe that WSL2 debugging gives you a real sweet spot between production realism and your actual productivity, just getting things done. So the things about WSL2 that we love is that it's really fast and easy to install. It's fast in and of itself. It doesn't require you to have a bunch of other tools sitting in the background. So again, if production realism is what you're after, then maybe a container is the best solution. And if you need to connect directly to a production environment, maybe remote debugging over SSH is the better option for you. But if you just need to verify and validate some things locally, quickly, and easily, then we want you to consider Windows Subsystem for Linux too. So I'm going to hit into a demo to kind of really show off what I mean by fast and easy. I have been working, the problem space that I kind of want to introduce this to you with is with an open source project I have called DOSBlog. I have been using DOSBlog for some years now. And DOSBlog, I more recently converted DOSBlog, which is a system web old school IIS web forms application, and I've been converting it to ASP.NET Core, and with the intent that it should be run in a cross-platform fashion. More recently, colleagues have been using it, and one of them realized that there was problems on Azure App Services for Linux that I couldn't replicate on my Windows machine. So he proposed, hey, go install WSL2 and investigate. And so what I'm going to do now is just kind of show you how we use WSL2 within Visual Studio, and then track down a bug that is only has impact on the Linux environment. Okay, so I am going to go ahead and open up my DOSBlog project here. And as you can see, immediately in the launch profile, sorry, my mouse is all over the place. Originally in the launch profile, you'll see we have a new option, WSL2. Now, in order to get that, you will probably realize that those are kind of driven by the launch settings file. If you look under your project file, under properties, you'll see launch settings, JSON file. And in there, you'll see a defined JSON object here with WSL2. I'm going to go ahead and get this started while I'm waiting on this. I'm going to go ahead and launch that. And what I can do within this launch settings, you can see that there is a command line, WSL2, and a distribution name here, which is left blank. And really what that's doing is it's using the command line tool, the CLI, for Windows Subsystem for Linux. And if I list them, I can see the list of Linux distros I have locally. I actually have Ubuntu 18.04, I have Ubuntu 20.04, I have Debian, and the default one right now is Ubuntu. So in my actual launch settings program, the actual one that will pick up is my default. So if I actually wanted to change that, I could actually do WSL-S and change it to Debian and have Debian as my default if I wanted to. Alternatively, I could go into my launch settings JSON file and add other options. So I could literally specifically name a distribution that I want to debug as. For now, I'm fine with Ubuntu. My colleague is running Ubuntu, so I'm fine with that. So I'm going to go back to my project, and I should be up and running here momentarily. In fact, we should be running momentarily. Here we go. Seem to try that again. And as you can see here, it actually is building out an output directly to, you can see it's mounting everything here, building directly into the Linux distro rather than your local machine. And these are all being loaded into WSL2. So you can see my output running there. Let me see this. I can get this running one more time. And that's still going. Hopefully this will do it. 1 second. Give that just a few seconds more and hope that my local debugging will start. See, looks like it's not coming from me. Okay, I'll continue with this. In principle, what was happening here, I don't know if it's pretty obvious to some of you who are Linux developers. I made an assumption about this particular project that assumed file names all began with a /. Unfortunately, that's not the case for Linux. And essentially what I should have done here, and that became obvious once I was able to start debugging in with WSL, is that there are there's actually options that allow me to decide what the directory separating character should in fact be. And so this allowed me to kind of see what values were being passed in. I could see it wasn't a Windows directory. I could see that there was other assumptions I needed. And essentially using path.directory separator character allowed me to realize that actually the data I assumed would be there was actually Linux based, and I needed to correct that. I'm going to go ahead and start looking at our next section here. And debugging tips and tricks. Let me switch to doing my regular debugging. Hopefully I have more luck here. I'm going to start debugging here. So as we think about debugging more generally, I like the idea of thinking about my debugging in a couple of different simple ways. I like to think about the data that the debugging session has, and my objects have particular values, set of values that I'm interested in. So I like to think about the data first. Then I like to think about the call stack second. I like to think about the context in which my application is running and which call stack it's running in. And then finally, I like to think about the big picture. What are my threads doing? What are my tasks doing? And so as I think about that, I think about the different ways I can use Visual Studio to kind of get me close to all of these particular types and techniques of debugging. So let's move now back into Visual Studio. Hopefully I've had more look here. It's still loading here. Excellent. Close down some of my other windows here. All right, perfect. All right, so I've logged in now. I'm going to go ahead and set a breakpoint right here. And I'm going to go to my blog. I'm going to select a particular post and hopefully hit the breakpoint. Perfect. Okay, I've hit the breakpoint. Now, as I said, I like to think about data first. What are objects and what are my properties of those objects? So for that, I like to think about pinnable properties. So for example, I could look at this object here and see it has all these particular properties. And I'm actually interested in seeing the author information. I may be also interested in seeing the entry ID, and I might be interested in seeing the title. And what that does for me, that pinnable property, being able to print that allows me to have this information pinned to a particular location in source. So as I'm kind of debugging my issues, I can use this as a mechanism for kind of highlighting the most important data for me as I move throughout my application. So that's pinnable properties. As you can see, I'm pinning to source at the moment, but I actually can unpin that and actually have it navigate with me as I go through the file. And I can see that information consistently with me. Obviously, this information exists in locals and in autos, but sometimes you kind of almost want to pop some information quickly and easily and consistently in a particular location as you debug. So that's pinnable properties. And then as you can see, I've kind of set this breakpoint right here. And there's technically, I actually want to start debugging this get comments method right here. But as you can see, I set a breakpoint on line 69, and that's supposed to be a breakpoint on a particular line of code. But technically, this is 69 to 77. And I actually want to step into this location. So if I actually hit step into, I'm always kind of confused about where I might be stepping into. Am I going to step into a get or a set? And there's obviously a bunch of gets here. There's a select query, link query select here. There are a bunch of other methods that get called. But I actually am interested in going specifically into this method. There's a nice little trick here I want to kind of share with you. If you right click in the window, you can step into specific and go directly to get comments. So I'm interested in going only to this one right here. So normally what I'd actually do is go find get comments and put a breakpoint in it. Well, you don't have to do that. You can simply right click, step into, and get comments. And again, now I can start diving in deeper and deeper into the call stack. I'm going to hit my step into, which is at F11. I'm going to go ahead and step in. I'm going to go down a little bit further into the call stack and actually one more step into the call stack. Because now that we've kind of thought about what data looks like, I actually want to look about what the call stack. So I like my call stack window to be right there with me. And the call stack's telling me I'm obviously where I am. But now if I wanted to, I can right click inside the call stack window and run to cursor. That allows me to pop back out. I've been pushing into my call stack. I can now pop back out of my call stack by hitting run to cursor, and that pulls me right back out, right? I'm now actually, I'm actually only one step deep. I've allowed it to run. And actually, of course, I can then go right back to the top of this call stack by run to cursor again. And then just again about navigation within here, within the call stack and within the method, within this particular frame, I actually can, if I wanted to repeat something, maybe I missed something or I set the breakpoint too late, I can go back up towards the top and pull my next statement via the yellow arrow and kind of reset where my next statement is and start to execute again. And I can hit continue there and go back to my breakpoint. What I can do is if I want to go forward, I can hover over a line of code and run to a particular line of execution. So I can run further into my code by hitting that particular line of code. So again, the idea here being I can not only see more data, but I can navigate my call stack. I can navigate around in my code. I can go backwards. I can quickly move forward. All these are kind of help you save a bit more time as you kind of debug. So in addition to this regular everyday debugging on the call stack and with data that you have, I also like to think about the big picture, the even bigger picture of the call stack is really the thread in which that call stack is running in, or the task that that particular call stack is running in. So I also have another quick application here I want to show. This is from my friend Christoph. He's a brilliant diagnostics and debugging engineer, and he created this app that allowed you to think about things in terms of threads and tasks. And what we're going to have here is 3 people that are making orders, and we see that the orders being processed. And after they're processed, at some point, this application gets stuck and doesn't process any more orders or add any more orders. And now there's really no information within the data objects themselves or within the call stack that can help me at this point. So now I need to take an even bigger step back and think about what's happening to my threads. And I think a really powerful tool to doing that is the parallel stacks window. So I'm going to go ahead and pause. Obviously my app's no longer responding. None of the orders are being processed or added. So I'm going to go ahead and pause the app. And I'm going to navigate to the parallel stacks window. And it now is a slightly different view. You may have noticed Visual Studio has always had a threads window, which presents a tabular view, kind of like a row-by-row view of threads. And we've always had the tasks window, which again throws a row-by-row view, a tabular view of the tasks. With the parallel stacks window, we have a more visual cue about what's going on with your application. It allows you, one of the really important improvements we've made in recent previews and recent releases is additional annotations within the call stack to let us know what might be going on and the relationship threads have with each other. So as you can see, the current call stack that I'm looking at in the bottom right corner here, I am waiting on a lock. I can see that it's annotated as a frame, and it says that it's waiting on a lock that is being held by thread 28492. And so I can now see by this view is that I've got 31 threads that have the exact same call stack, and I have 30 of those threads are waiting on thread 28492. I then have one thread that is waiting on thread 11020. And I can actually go through and figure out actually what's become just obvious to me. And I'm hoping this is large enough for you good folks to see. Let me just scroll in a little bit here. But 28492 is rating on a lock owned by 11020. And if I scroll over here, I just think I saw 11020 is also waiting for a lock owned by 28492. What that has quickly told me is that 2 threads are essentially waiting for the other thread to release something so they continue processing. That is what we describe as a classic deadlock scenario. And by quickly inspecting the large picture, the big picture presented by parallel stacks, I get to see what's going on between my threads. Again, that's the big picture view. Parallel stacks comes in 2 iterations. You can think about it as threads and tasks. So I can actually switch to the tasks view and start to see that, again, it's got these deadlock symbols all over the place. It's even more obvious now that, in fact, I'm in a deadlocked scenario. Everything is waiting on something else. And unfortunately, that something else is waiting on the original thing. So I'm in a deadlock scenario. This is probably a low CPU deadlock scenario. All right. Let me move on for the last few minutes here. And let's talk about perf. So everybody that starts producing code and putting it into production, I think sometimes we get tricked into thinking that the only time we can measure is when we go to production. However, we have perf tools inside Visual Studio that allow you to measure how effective and how efficient your code is or is not running. So I'd like to introduce you to the Perf tool today, so you can quickly get started with kind of analyzing methods and code that you have running locally, and just to see how it's running. You may be surprised at which parts aren't running as efficiently as you think. Let me show you what I mean by that. Let's open up one more project. So I have one more project to share with you. It's called Buggy Demo Code. It's an application I've created with the express purpose of creating code that doesn't necessarily look obviously wrong, and using that as a mechanism to describe what the things we want to measure potentially before we go into production. So if I wanted to measure this particular function, this poor regex function, I'm kind of giving away my punchline here. But if I wanted to measure this, I could go to, I would set it as a release project. I would go to debug and I would start the performance profile tool. And then I could start profiling specifically around .NET Async and CPU usage in this instance, but I could also do things around counters. I could measure how long my database queries are taking, how much allocation's going on, how much memory my application's using overall. There's a bunch of measurements we can do, and we're supporting, and we're building up more and more capability there. So quickly, I want to move on. I've just got a couple of minutes left here. So I actually captured this particular trace a few moments ago. I didn't want to do it while I'm presenting. And as you can see, I took a trace. I saved this trace, and I took a trace for 42 seconds. So that's the timeline you're seeing across here. And in the y-axis, you're seeing the percentage of the CPU usage. As you can see, when I started up, there was a little bit of activity there. But the real activity came when I actually started to test my code. And as I started to test my code, it became obvious where the inefficiencies in my code existed. Now, as I said, the code I showed you had a really big for loop that was writing to a disk and doing some small calculations. I had a big while loop that was writing to a disk, and then I had a single regex search on a relatively small URL. And what we end up seeing isn't that the for loop or the while loop ended up with the CPU usage, but that regex was actually really, really badly designed. And as you can see, it actually ended up consuming about 94.9% of the resources, all focused on this regex. So what I can do here is use this hot path to really allows you to see which path your code took and which one is the most likely to allow you to find improvements. And then if I click on that particular path, it kind of lands me directly in my code. And this code is supposed to simply detect that I've got a valid URL. Unfortunately, it's so badly designed that it ends up consuming a bunch of my CPU. So that brings it to a conclusion. I think I am right at time. If I could, once again, highlight some of the releases that we've had. We've got, again, as was mentioned in the previous session, dev environments in the cloud with code spaces, AI-assisted productivity. Check out the GitHub actions around workflows that you can do that directly in Visual Studio now. So you can think about your CI/CD and your DevOps scenarios directly in Visual Studio. Git workflows are amazing. Again, I am doing most of my open source work with GitHub using Visual Studio now. I don't need to actually do the command line stuff anymore. I think you'll love that. Consider again the Linux diagnostics, the area I just spoke about. The WSL2 native in Visual Studio gets released with the 16.9 preview. Please check that out. And my team just released debugging managed Linux core dumps directly in Visual Studio. So you can take a memory dump on a Linux box directly in your production environment, get that onto your machine with Visual Studio, and drag and drop that directly into Visual Studio and start a bunch of analysis, including on the parallel stacks window and other things there. That kind of brings me to the end. Thank you so much for joining me. Again, my name is Mark Downey. You can reach out to me at PopperString on Twitter with any questions you have or follow-ups. I would love to hear from you. Thanks so much.
Thank you, Mark. That was a fantastic talk. Not to be biased or anything, but debugging is is awesome. Or I mean, debugging can be frustrating, but the tools that Visual Studio has certainly aren't.
Right, right.
Cool. So we have one question from. Oh no, we got a couple. Okay, cool. So first question, the Stonehead asks, what are the benefits of debugging in WSL2 versus inside a Linux Docker container?
I would say it's all about speed and convenience. I think if you want to really focus on a scenario that feels like production, then maybe Docker is the better alternative. If, however, like me, I was kind of just trying to figure out the lay of the land and figure out directory structures and how that worked, then I think WSL2 is just quick, easy, productivity is high. I don't necessarily have to have the overhead of installing a bunch of services. It took me just minutes to install WSL2. So again, it just depends on your scenario. If production realism is what you really want locally, then yeah, absorb the cost of the overhead associated with Docker and virtual machines. If, however, you just need to quickly check something, WSL2 is a really, really good option.
Cool. So similar, but maybe just more like auxiliary too. Luis Brian Orexon asks, WSL2 can give you a lot of information, and can all that information be shown with Power BI as well?
Okay, so this sounds like a more of a WSL2 question, and I'm not really sure, but I will follow up with you, Brian, online and see if I can get the answers you need to that.
Cool. F Small asks, what's the best practice workflow when dealing with threads and the parallel stacks window?
So again, I think the question, I guess I'll answer the question broadly. I think the idea here is that we want to think about, when you want to think about the big picture of your application. For example, if I start memory dump debugging, I start with the parallel stacks window because I'm thinking about what is the entirety of my apps doing, right? So if I have an app that is multi-threaded, that is got lots of tasks doing a lot of things, I always start my debugging and diagnostics with the parallel stacks window because that gives me the big picture view. And then from the parallel stacks window, I get to narrow in on a particular call stack. If, for example, I've got runaway threads, then I'm kind of interested, or threads are being blocked. I kind of think about, well, what call stack should I pick out from the parallel stacks window? Because that's the big picture idea. Now, if I'm thinking about data, yeah, then I'm going to tie in to pinnable properties. I'm going to look at the locals window. But if I'm thinking big picture, I'm thinking threads, then I start with parallel stacks. I think it's a great feature.
Great. And I think we have time for one more question, also about the parallel stacks. So Dr. Edgar Knapp asks, seems to me one can find wait for cycles automatically from the info the thread diagrams contain. Is this true, or is this in the plans?
That's a really, really good question. If I hear that question correctly, I think you want to know how long something's been waiting on a log, maybe. And if that's the question, that would actually be really, really interesting additional information to add. And I'll make sure to follow up with you because I'm really curious about the idea you have. But what I'm thinking I'm hearing is that you want to know how long something's been waiting for a lock to release. And that would be really, really interesting, especially when you are thinking about the constant moving parts of threads. And that a deadlock may not always be the most common scenario, but certainly waiting for too long for a lock to release is a common scenario. And I think that additional information would be very, very powerful. So yes, I think that would be a really, really good idea.
I also think that would be a really good idea. I can see scenarios where you're just trying to determine what the issue is for time help.
Yeah.
Sweet. So that is all the time we have. Thank you so much, Mark. Please go check out all these cool debugging tools. It'll make your life so much better, we promise. And yeah, thanks for joining us, Mark.
Thank you for having me. Thank you. Appreciate it.